Good afternoon, everyone. In the previous lecture session, we already started the series solution of the ordinary differential equation. Right? Quickly we revise this and then we practice the more problems based on that. This is the introduction, why we need the series solution in this. So the ordinary differential equation, we know that some kind of the function, some kind of the equation when the differentials y double dash, y dash and all that, this is multiplied with the polynomial term, and that's why we can't solve directly. That's why we need the series solution for the ordinary differential equation. Yes, then we discuss the power series definition and infinite series of the below form. Is called a power series in the powers of the x minus x0. In the notation, we can write it like that. Summation over k equal to 0 to infinity. Ak x minus x0 raised to the power k is equal to a0 plus a1x minus x0 plus a2x minus x0 whole square up to 0. Then we discuss the analytic function. Function is seen to be the analytic at a point x0 if it can be expressed in a power series near the point x0. And then after we discuss how to find the ordinary point, singular point, regular singular point, as well as the irregular singular point of the given differential equation. This is the notation, this is the form of the given differential equation. Now the y double dash coefficient p0x, right, divide by this whole equation by the p0x, but the condition is this p0x term is not equal to 0. Then we give one notation for p1x by p0x denoted by the capital P of x and p2x by p0x denoted by the q of x. Okay. And then after we discuss using this equation, the ordinary point and the singular point. In the previous equation, x0 is called the ordinary point of the differential equation if p of x and q of x both are analytic at x0. Both are analytic. That means here we are not getting any kind of the points when the p of x and q of x values becomes the infinite. Okay, and at least one of the functions is not analytic at x0. Then x0 is called a singular point. That means we are getting any one or more points, right? When the functions becomes infinite, then at that point the function is not analytic. Now the regular singular point, RSP and IRSP. A singular point is called the regular singular point if this is satisfied two conditions. Which two conditions? First condition is x minus x0 p of x, and another one is x minus x0 square q of x. If this both the conditions are satisfied, or if this both the conditions are analytic at x0, otherwise it is known as an irregular singular point. And we discussed one problem also, find the ordinary points, singular points, and we also added that find also the regular singular point of the given equation, given differential equation, right? As per the definition, y double dash coefficient is 1 minus x squared. Divide with this whole equation. Then compare with this equation, y double dash plus p of x y dash plus q of x y. Then identify P of x and Q of x. Now check that when this function, when this P of x and Q of x this becomes infinity for which value of the x. Right into the denominator, the term is 1 minus x squared. You can also find it like that also. 1 minute. Yes, you can find like that. 1 minus x square equal to 0. Therefore, x square is equal to 1 implies we are getting x equal to plus or minus 1. That means at that point, the values are the 0. Therefore, P of x and Q of x are the converting into the infinity, or in another sense that are not analytic. Okay, 1 minute. Yes. And that's why these 2 points are known as the singular points, and other all the points are known as the ordinary point. After finding the singular point, individually check for each and every point, right? The 2 conditions of the regular singular point are satisfied or not satisfied. We checked over here for x0 equal to 1 as well as x0 equal to minus 1. Okay, now the second problem. Second question. Classify the singular point of the differential equation x square y double dash plus xy dash minus 2y equal to 0. Classify the singular points. That means you have to identify the singular point as well as the singular points are regular or irregular. Okay. 1 minute. Now, first we write this given differential equation x square y double s plus xy dash minus 2y equal to 0. This is our equation number 1. Now, equation number 1 divide by x square. Therefore, we are getting y double s plus x by x square. Therefore, 1 by x y dash minus 2 by x square y equal to 0. Equation number 2. Now compare with compare with y double s plus p of x y dash plus q of x y equals 0. Therefore, p of x is equals 1 by x and q of x is equals minus 2 by x squared. Now, everyone, please type the point when p of x and q of x are not analytic at that point, right? Write your answer into the chat box, at which point P of x and Q of x becomes infinite. Quickly type your answer into the chat box, everyone. Yes, Kinjal, very good. Yes, other student, very simple. For which value P of x and Q of x becomes infinite. When you enter the value of the x into the denominator. Yes, Saurav, unmute yourself. Saurav. Saurav, please unmute yourself. Yes, Saurav. When you put it over here into the denominator 1, then what is the value of the P of x?
Ma'am, px equal 1.
Yes, and our goal is for which value of the x, this is converting into the infinity. Okay. Yes, Kinjal. 1 by x equal to 0. Therefore, x equal to 0. When you put it over here, x equal to 0 into the denominator, right? Then it converts into the infinity. Therefore, these both are not analytic. Very simple. For this value, you have to put it equal to 0. 1 by x equal to 0. That why it's but obvious. X is equal to 0. Right? Therefore, P of x. Yes, Raj Kishore, wait for the minute. After completing the whole question, I will show you. P of x and Q of x both are not analytic. At x equal to 0. Therefore, x equal to 0 is a singular point. Okay. Now, we have to check that this singular point is a regular singular or not. Now, for x0 equal to 0. Now, we have to check that these two conditions. Which two conditions? X minus x0 into P of x and x minus x0 square into Q of x. Okay, now the first condition, x minus x0 into P of x. Now, what is our x0? Our x0 is the 0. Therefore, x as it is. What is the value of the P of x? This is 1 by x. Therefore, xx is the cut it out. Remaining, the answer is the 1. And the other condition, x minus x0 square Q of x. Our x0 is a 0. Therefore, x square into value of the Q of x is minus 2 by x square. X square is the cancel out, remaining is the minus 2. Again, we check that the value of the P of x and Q of x. Yes, this is 1 by, this is minus 2 by x square. Right? Therefore, x square cancel out, minus 2. And both the answers are the finite. Therefore, x minus x0 P of x and x minus x0 square Q of x both are analytic at x0 equal to 0. Therefore, x0 equal to 0 is a regular singular point, right? If for any one condition, if we are getting the answers infinite, right, then this point is the irregular singular point. But here, for both the conditions, we are getting the finite answer. That's why both are analytic And therefore, x0 equal to 0 is a regular singular point. Clear all the steps. Any doubt, then please raise your hand first. This is our question number 2. And if in this question, find also the ordinary point, then what are the ordinary points? All the points are the ordinary points except x equal to 0, right? Remaining all the points are the ordinary points when the functions are analytic. Anyone remaining to note it down this slide, then please raise your hand quickly. Yes, Rajkishore done. Then quickly type yes into the chat box. Rajkishore. And afterwards, we check that x0 equal to 0 is a regular singular point or not, right? We check that this condition. Okay, now the next question. Classify the singular points of the equation x cube x minus 2y double dash plus x cube y dash plus 6y equal to 0. X cube x minus 2y double dash plus x cube y dash plus 6y equal to 0. Everyone start the solving process with me and type your answer regarding the singular points into the chat box. Quickly do it, everyone. Very simple process. You can do it yourself also. X cube x minus 2y double dash plus x cube y dash plus 6y equal to 0. Now, divide this equation divide, right, by x cube x minus 2. Therefore, y double dash plus x cube by x cube x minus 2. This is cut it out, y dash plus 6y x cube x minus 2 y equals 0. Therefore, the remaining equation after simplification y double dash plus 1 by x minus 2 y dash plus 6y x cube x minus 2 y equals 0. Okay. Now regarding to the singular point, which term we divide by x cube x minus 2. Therefore, put it this term equals 0. X cube x minus 2 equal to 0. Therefore, x cube equals 0 and x minus 2 equal to 0. Therefore, we are getting 2 points, 0 and x equal to 2, right? These 2 points are the singular point when the function is not analytic, or in the other words, we are getting for this point, the p of x and q of x value is the infinity. Done, everyone? Yes, Kinjal, Mihir. Okay. Now, if you want to compare them, right into the next slide, please compare with y double s plus p of x y dash plus q of x y equals 0. Therefore, we are getting p of x is equals 1 upon x minus 2, and q of x is equal 6 by x cube x minus 2. 1 by x minus 2 and q of x 6 by x cube x minus 2. Therefore, p of x is not analytic at x equal to 2, because when you put it denominator equal to 0, x minus 2 equal to 0, therefore we are getting x equal to 2. And q of x is not analytic at x equal to 0 and x equal to 2. Right? Because this term equal to 0, therefore x equal to 0 and x equal to 2. When we put it over here 0 or 2, then q of x is converting into the infinite. Therefore, x equal to 0 and x equal to 2 are singular points. Okay. Now, one by one, we check that these are regular singular or irregular singular point. Just Kinjal, unmute yourself. Kinjal.
Yes, ma'am.
Yes, Kinjal. Which is the first condition?
X minus x0 into p of x.
Okay, and here our x0 is a 0. Therefore, x, what is the value of the p of x? Is here 1
1
upon
upon x, x
Hmm.
minus.
x minus 2. Right? Now, no one term is cancelled out. X by x minus 2. Now we apply over here 0. Therefore, 0 by 0 minus 2. Therefore, the answer is the 0 and this is the finite one. Clear, everyone? In place of x, apply the value of the x0 and x0 is 0. Now the another condition, x minus x0 square q of x. Yes, Kinjal? What is the value of the q of x?
6 upon x cube into x minus 2.
And 6 upon x cube into x minus 2. Therefore, first we simplify that, x square cancel. Remaining is 6 upon x, x minus 2. Okay, now we apply over here in place of x, x0. Now x0 is here 2. Therefore, 6 by 2 and 2 minus 2. which is infinite, right? Therefore, the second condition is not satisfied. Therefore, this point is regular or irregular, Kinjal?
Irregular.
Yes, is not analytic. Yes, now you can mute yourself. Thank you very much. Is not analytic at x0 equal to 2, right? You have to check that the another condition for x0 equal to 0 and the first condition for x0 equal to 2, right? Because for x0 equal to 2, this second condition is not satisfied. And for x0 is equal to 0, check that the second condition is satisfied or not, right? Analytic at x0 equal to 2. Therefore, x0 equal to 2 is a irregular singular point, right? This is for x0 equal to 2. Now you have to check that the first condition is satisfied or not. X minus x0 px. Therefore, x minus 2. 1 by x minus 2. Therefore, answer is 1. Yes, it's analytic. But the second condition is not satisfied. In the same way, for x0 equal to 0, we check the second condition over here. And this is 0. And the another condition, x minus x0 square q of x. Therefore, x square 6 by x cube x minus 2. And the remaining is 6 by x minus 2. When we put it 0, it's also infinite. Therefore, x0 equal to 0 is then IRSP also. Here also the another condition is not satisfied, right? Therefore, both the points are irregular singular point. Clear, everyone? This is for x0 equal to 0. Second condition is not satisfied. This is for x0 equal to 2. First condition is satisfied, but second condition is not satisfied. Right? In both the points, second condition is not satisfied, and as per the definition, the condition is among this both the conditions, if anyone is not satisfied, then the singular point is an irregular singular point. Everyone clear the whole question? Again, we will see the whole question. Classify the singular point. Classify means first you have to find the singular point and then after you have to classify. This is regular or the irregular. Okay. Very simple. Y double dash coefficient. Select this whole polynomial term, divide by this term, the whole equation, whole differential equation. Then after compare with this form, y double dash plus p of x y dash plus q of x y equal to 0. Then identify the value of p of x and q of x. Now very simple. This denominator x cube into x minus 2 equal to 0. Therefore, we are getting x cube equal to 0, x minus 2 equal to 0. Therefore, x equal to 0 and x equal to 2. When these two values of the x, we are entering in p of x and q of x, then p of x and q of x becomes infinite. And that means that are not analytic at that point. And these points are known as a singular points. Okay, remaining all the points. The function is the analytic, and that's why these all remaining points that are known as the ordinary points. Okay. Now, after finding the singular points, we have to classify these are regular or irregular. Now we check for the first one, x0 equal to 0. Therefore, x minus x0 p of x. X as it is, x0 is the 0. Therefore, no need to write. Put it over here, p of x value. Now enter here x equal to 0. Therefore, 0 by 0 minus 2. Therefore, answer is the 0. And another condition, x square into q of x. Therefore, remaining is this term. Now we apply x equal to 0 over here. Therefore, 0, 0 minus 2. Therefore, 6 by 0, and this is the infinity. Therefore, one condition is satisfied, one is not satisfied. Therefore, this point is an irregular singular. And the same way, we check for the second one, and the same process of apply over here. And here, the second condition, again, not satisfied. Therefore, both the points are singular points, but both are the irregular singular points. Yes, Deepak, clear, Sudarshan, Mihir, Hanuman, Raj, Rishi, everyone. Any doubt regarding that? Sanatan, Kevin, Ayub. Unmute yourself. Ayub Ahmed.
Yes, ma'am.
Why are you joining late, Peter?
Ma'am.
Yes, write your reason into the chat box quickly.
Okay, ma'am.
Okay, now one more question. And this question, you have to do it yourself. Discuss about ordinary point, singular point, regular singular point, and irregular singular point. For the differential equation, x cube, x minus 1, y double dash, plus 3, x minus 1, y dash, plus 7xy equal to 0. Now everyone, please do it yourself and write the singular point into the chat box quickly. Apply the same process of the previous 2 to 3 questions, right? And write the singular points of this differential equation quickly in the chat box. I'm waiting for your answer. Quickly write out your answer. Which are the singular points? First, divide the whole equation by the term is multiplied with the y double dash. Then compare with the normal form, normal equation. and identify P of X, Q of X, and then find the singular points. Yes, quickly do it, everyone. Yes, Kunal, Kinchan. Yes, sir, very well done. Other students, please type your answer also. Yes, Kunal, unmute yourself. Kunal,
Yes, ma'am.
yes. Please explain one by one steps, right? First, I'm writing over here this differential equation. What is the next step, Kunal?
Yes, ma'am.
Yes, please tell me the next step. Divide by x cubed x minus 1. Therefore, y double s plus 3 x minus 1 cancel out. Therefore, x cube is the remainder. Plus 7 x by x cubed x minus 1. Therefore, 1 time x is cut it out. Therefore, finally we are getting p by x cubed y dash plus 7 by x minus 1y equals 0. Everyone get it this equation? Then please raise your hand. Quickly raise your hand. Now compare with, okay, those who are getting the singular points, so please check that this both the points are regular or irregular singular point. Saurav, Kunal, Kinjal, please check that and write your answer into the chat box. Points are regular singular or irregular singular. Compare with y double dash plus p of x y dash plus q of x y equals 0. Therefore, p of x is equals and q of x is equals. Move the previous PPT 3 by x cube and 7x x minus 1. 3 by x cube 7 x minus 1. Now very simple. For this denominator, we take it 0. Therefore, quickly we get it the value. X equal to 0 and x equal to 1. Right? X equal to 0 and x minus 1 equal to 0. Therefore, x equal to 1. Therefore, P of x and Q of x are not analytic. At x equal to 0 and x equal to 1. Therefore, x equal to 0 and x equal to 1 are singular points. Okay. If you enter over here 0, therefore 3 by 0 is infinity. In this Q of x, 7 by 0 into x minus 1, then this is infinity. And 7 by x, 1 minus 1, therefore this is 0, therefore this is again infinity, right? Therefore, when you enter value 0 or 1 in P of x, then after Q of x, then for this both the term values, P of x and Q of x converting into the infinity, that means not analytic, and therefore these 2 points are the singular points. Clear? Okay, now we check for the singular point. Are the regular singular point or irregular singular? Before that, right? Another question is here. Discuss about ordinary point. Okay. Anyone unmute yourself and tell me what are the ordinary points, Kinjal? Ordinary points. Kinjal, unmute yourself.
Yes, ma'am.
Yes. Any idea regarding the ordinary points?
Yes, ma'am. Except 0 and 1, all are ordinary.
Except x equal to 0 and x equal to 1, all points are ordinary points. Okay? Because for any point, right, if you take it x equal to 2, now put it over here, 3 upon 2 cube, 3 by 8, right? This is the finite value. Now apply over here 2, therefore 7 by 2, 2 minus 1, therefore 7 by 2, and this is also finite. And for these values, we are getting the finite answer. These are the analytic and these are known as the ordinary point. If you want to enter 2, minus 2, 3, minus 3, 4, 5, any number, right? All the points are the ordinary points. Now we first check for x equal to 0. This is regular or irregular. For x 0 equals 0. The first condition, x minus x0 p of x, and another condition, x minus x0 square q of x. X, here x square, value of the p of x, this is already into the previous slide, 3 by x cube and 7 by x minus 1. 3 by x cube, 7 by x minus 1. First simplify, x one time cancel, here square, remaining is 3 by x square. Okay, now 3 by x square, that means 3 by x0 square, and which is infinite. And here x cancel out, 7x by x minus 1, therefore 7x0 by x0 minus 1. Therefore, when we enter the 0, therefore 0 divided by minus 1, therefore answer is 0. Therefore, x minus x0 p of x is not analytic. Why not analytic? Because we are getting the infinity over here, right? Here, when you apply 3 by 0, this is infinity. At x0 equal to 0. Therefore, x0 equal to 0 is a regular singular point. Okay, now everyone in the same manner check for the point 1, x0 equal to 1, and check both the values are finite, then this is the regular singular point. Otherwise, this is irregular singular. Right? Here one condition is not satisfied, therefore irregular. Now check for the x0 equal to 1 quickly, everyone. Quickly check that. Very simple calculation. And I need everyone's answer into the chat box quickly. Here apply x0 equal to 1. This p of x and q of x remains as it is. Your point is changed. Now your x0 is the 1. Quickly check that, everyone. Yes, come on, do it fast. You can do it. Quickly do it. If you have any doubt, then you can raise your hand. Otherwise, quickly calculate in your book and type your answer. This is regular singular or irregular. Yes, Karnavi, Hanuman, Mihir, Deepak. Yes, Ravi Kumar. Raj, Kevin. Yes, Kinjal, very good. Other student, quickly check that and type your answer. This is regular singular or irregular singular. Yes, Kunal, very good. No, Roshan, it's not correct. Check it again. Clear, everyone, in your mind? For one and second condition. For first condition, if you are getting the finite answer, and for the other, again you are getting the finite answer, then this is regular singular point. But if any of the one condition, if your answer is the infinity, then this is irregular. Yes, Karnavi, very good. Roshan, check that and type your answer again. Other students, yes, Rishi, your answer is not present in the chat box. Nitish Kumar, Roshan. Yes, Roshan, done. Vikas Kumar. Both the Vikas, 9 and 10. Yes, I'm waiting for your answer. Quickly type it, everyone. Kevin, Sanatan, Ayub, Saurav, Ajit Kumar, Ravi Kumar, Mihir, Deepak, Trilok Kumar. Yes, Rishi. Yes, remaining students. Quickly check that. Very simple calculation. Trilok Kumar. Deepak, unmute yourself. Deepak. Yes, Rishi, unmute yourself. Rishi. Rishi, are you getting my voice? Yes, Rishi, unmute yourself. Unmute yourself. Okay. Some network issue, no problem. Yes, Kunal?
Yes, ma'am.
Yes, what is the value of the P of X, Kunal?
P of x 3 by x cube.
Yes. P by X cube. Yes. And X minus X0 square Q of X. X minus 1 whole square. What is the value of the Q of X?
7 by x square minus 1. X minus 1.
X square.
X minus 1.
Okay. 7 by X only. 7 by X. X minus 1. I check that the value of the Q of X again is 7 by X. Okay. Now we simplify that. Therefore, 3x minus 1 divided by x cube. And here 7. One time this is cancelled out. Therefore, 7x minus 1 by x. Okay. Now here x0 minus 1 by x0 cube. 7 x0 minus 1 by x0, and x0 is the 1. Therefore, 3, 1 minus 1 is the 0, divide by 1. 3 into 0 by 1, therefore 0. And here, 7 into 0 by 1, therefore 7. I'm sorry, 0. Therefore, both are analytic. At x0 equal to 1. Answer is the 0, but our original base point we are taking 1. Therefore, x0 equal to 1 is a regular singular. Okay. X0 is equal to 1 is a regular singular point. Again, check the whole question. Yes, Roshan, you type into the Q of X value, I think so, yes. Yes. Discuss about ordinary point, singular point, regular and irregular. This is our differential equation. We divide by x cube x minus 1. Therefore, we are getting after simplification this kind of the differential equation. Compare with this notation, y double s plus p of x y dash plus q of x y equals 0. P of x is equal 3 by x cube and q of x is a 7 upon x, x minus 1. Now, for finding the singular point, very simple, this denominator equal to 0. Put it, this denominator value equal to 0. Therefore, when we solve this equation, that's why we are getting x equal to 0 and x equal to 1. And for that point, P of x and Q of x are not analytic, therefore singular points. Remaining all the points are the ordinary points. And individually, we check for every singular point, this is regular or irregular, right? If these two conditions, any of the one is not satisfied, then this is irregular, Otherwise, this is regular singular point. Now, please write everyone the 2 questions for your practice, right? In the homework, right? You have to do it, this 2 question yourself and discuss ordinary point, singular point, regular singular point, and irregular singular point. Okay? Our differential equation first is x square y double dash minus 5y dash plus 3x square y equal to 0. Okay, we will discuss answer of this question, right? In our next session, in the next lecture. X square plus x minus 2 whole square y double dash plus 3 x plus 2 y dash plus x minus 1y equal to 0. Okay, you have to check that singular point, ordinary point, regular singular. Yes, Saurav? Regular singular point or irregular singular point, right? These 2 questions. And we discuss answer of these 2 questions in our tomorrow's session. Okay, any doubt regarding this 2 questions? Then you can raise your hand. Attendance is already taken from your participants list. Thank you very much, everyone. Now you can leave this meeting. If you have any doubt, then you can unmute yourself and you can ask the questions. Otherwise, you can leave this meeting. Please note it down these 2 questions and solve in your lecture notebook, right? And when tomorrow's session will start, you have to type this both the questions answer. Okay, thank you very much. Have a good day.